Hello lovely people, welcome back to my channel. Today we are going to look at continuity and differentiability of functions, of piecewise function, that is further studies mathematics. We are going to explain the concept of continuity, discontinuity, and also differentiability of the function. We have a question. Let's go straight into the question, and then as we go on, we'll explain every basic step or concept needed here. They say for a given function, this is our function, which is a piecewise function. Sketch the graph of f of x. So let's go through that process. They want us to sketch the graph of f of x. Let's have our Cartesian. Remember, green lines will be provided for you if you are doing this. So we have two functions there. We have the first one as y equals to 2x plus 1. And we have the second one as y equals to x plus 3. But remember, these conditions must be made for each of them. Now let's look at this. This is a linear function, this is a linear function. For both of them, we just need the x and y intercept to sketch quickly. Here, my y-intercept is, if I make x 0, I have 0 and 1. That's my y-intercept. And my x-intercept is making y 0. So I have 2x plus 1, so I have x equals to negative 1 over 2. So my x-intercept will be negative 1 over 2 and 0. I have those two. Let's come to this. My y-intercept is 0 and 3. And my x-intercept, if I make y 0, I have x plus 3, I will have x equals to negative 3. So my x-intercept will be negative 3 and 0. So with these two, I can sketch both graphs. So let's choose our scale. I'm going with negative 2, intervals of 2 for y-axis. I'm also going with intervals of 2 for x-axis. The same time here. Now, the first graph says 0 and negative. 0 and 1 is my y-intercept, and then I have negative half, and 0 is my x-intercept. If 1 is here, this is negative half, so this will be our graph. Then remember that they gave us a condition. They said that x must only be a value that is less than or equals to 2. X must only be a value that is less than or equals to 2. So this graph can never escape this. So it must be less than or equals to 2. So we can only take this part, it cannot get over 2. So that is the graph of this function. Let's look at the second function. We have 0 and 3 as our y-intercept. And then we have negative 3 and 0 as our x-intercept. And the condition says that x must be a value greater than 0. So we can sketch this graph, value greater than 2, sorry. So if we sketch this graph, we will see that this graph greater than 2 can only start here. So every relative before that condition must not be part of that graph. So we can only have this graph going from there. So this is our graph of x plus 3, and this is our graph of 2x plus 1. So this is the graph of y equals 2x plus 1. Now, they are asking us if there is, this is graph, remember, what makes this graph or this piecewise function is the conditions, are the conditions. And if we don't respect these conditions, then the graph will be invalid. Now let's go to the second question. They're asking us, is f of x continuous at x equals to 2? If you sketch this, you see that they touch here at 2. Now what they want us to check is if it is continuous or if it is discontinuous. Remember, we have two types of discontinuity. It could be removable discontinuity or jump discontinuity. If it is not continuous, we also have to state the type of discontinuity that occurs at that point. Now let's look at this. For B, for us to check for continuity, we have to take the limit of that function. the limit of f of x when x tends to that value, we have 2 from the negative, is equal to the limit of that function when x tends to that value from the positive, and is it equals to the function of that value. Unless this condition is met, they are not continuous. All of them must have return the same value for us to say that this function is continuous. So let's look at this. 2 from the negative makes less than 2. 2 from the negative is x less than 2 from the negative. So we will have the limit of 2x plus 1 as x tends to 2 from the negative. Then greater than 2 is 2 from the positive. And for us to have that, this is the only equation that satisfies that. So we have x 2 from the positive. And then f of 2 will be when x equals to 2. Remember here we have double condition, less than or equals to 2. So we are looking at f of 2 for this. So we have 2 into 2 plus 1. Remember it can only be when it is equals to 2. Now let's see if these will give us the same thing. Limit of this function, if we solve into, we have 2 times 2 plus 1, 5. Limit, if we solve into for x, it is already simplified, so we don't need to simplify the limits for it. 2 plus 3 is 5. F of 2 times 2 is 4 plus 1, 5. You see, all of them are the same. All of them return the same value. So if all of them return the same value, we can say, therefore, the limit is continuous. Therefore, the function f of x is continuous at x equals to 2. Remember, it is continuous because of this condition. Only when this condition is satisfied, that is the only time we can say that a function is continuous at a given point. Please note, this is the condition. Now let's go to the next question. They are asking us also, is it differentiable at x equals to 2? What do we do for differentiability? Differentiability is similar to this, but what we check now is the first derivative of the limit of this function as it tends to 2 from the negative, and the first derivative as it tends to this from the positive. Now, for differentiability, it is slightly different, but similar to what we've done for continuity. So for differentiability, we are asking the limit, the first derivative of the limit of this function as x tends to 2 from the negative, is it equal to the first derivative of this function, the limit of this function as x tends to 2 from the positive. If they are equal, then the expression or the function is also differentiable at x equals to 2. So let's see. The first derivative when from the negative is this one. The first derivative of this is, remember, so we are looking at the first derivative of 2x. Let's do that right side. First derivative of this is, or the function is 2x plus 1. The first derivative of this function will be, remember, is 1 times 2 and then 1 minus 1. So it's 2. Derivative of a constant is 0. Let's go to the second one. The first derivative of the function when x is equals to 3. X plus 3, we have the first derivative of that function will be, remember, it's 1 minus 1. 0, 1 times 1, so first derivative of this function is this. So we have the limit of the first derivative when it tends to 2. The limit of the first derivative when it tends to 2 from the negative is 2. So the limit of 2 as x tends to 2 from the negative. Is it equals to the limit of the first derivative when it tends to 2 from the positive, which is limit of 1. Now, note that the limit of a function of a constant as it tends to any number from anything is still that. So the limit of this is 2 and the limit of this 1 is 1. So with this mathematical order, we can say they are not differentiable at x equals to 2. You see, they can be continuous, but at this point they are not differentiable. So for them to be differentiable, the first derivative, the limit of the first derivative of that function must be equal at the given point, approaching from the negative and also from the positive. So this is how we approach continuity and differentiability of piecewise functions. Please continue to share, continue to encourage others to subscribe, continue to bring in questions. I'm always here and I'm always willing and available to help. Enjoy the rest of the day.